This is the skills practice for section 9.7. We're looking at perimeters and similarity. We're going to find the value of each variable for each pair of similar triangles. So these two triangles are definitely similar by angle. We know all of these side lengths on this big triangle. We don't know any of the side lengths on the little triangle. But we do know that the perimeter of the little triangle is 30. That means the three sides add up to 30. So it could be any combination of numbers that add up to 30, but it's got to be a combination of numbers that ends up making proportional sides that correspond. So knowing that this perimeter is 30, it's important to figure out what this perimeter is. So to find the perimeter of a triangle, remember you add up three sides. So 18 plus 15 plus 12, we're going to add those up. That gives us 45. If you write a ratio of perimeters, remember that's the same thing as your similarity ratio. So 45 to 30, that reduces. I know what it reduces to, but I want to see if you know how to type it in. It reduces to 3/2. So here's what this means. The ratio of perimeters for this triangle to this triangle is 3 to 2. That means that all of these corresponding sides have a ratio of 3 to 2. This 18 goes with Z, not because they're both on the left side, but because they both touch a side that has an angle with one arc and an angle with no arcs. So 3/2 equals 18 to Z. 3/2 is also going to equal 15 compared with Y. Not because they're both on the right side, but because they touch an angle with no arcs and two arcs. So 3 to 2 would be the same thing as 12 to X as well. Now, we've gone over cross-multiplying tons and tons of times. You should know what you're doing with it at this point. So if you have three proportions, you should know how to get this variable by itself. We're going to take 2 times 18, divide by 3. That gives you 12. You're going to take 2 times 15, divide by 3. That'll give you 10. You're going to take 2 times 12, divide by 3. That'll give you 8. Now, double check to make sure that your perimeter is 30. 12 plus 10 plus 8. That equals 30. So you should feel good about these answers. All these corresponding ratios would be in a proportion 3 to 2, or ratio 3 to 2. That's how you do all of these. Use your perimeter, find the perimeter of the other triangle. That gives you the scale factor. Use that scale factor to write proportions. This next section, they're just asking us to determine the scale factor, or the similarity ratio. So these triangles are similar. Well, if they're similar, the smallest side is going to go with the smallest side. So 18 from the big triangle is going to go with 9 from the small triangle. And that's a ratio of 2 to 1. That's big to little. Now notice how number 10 switches it around. What's the ratio of the little to the big? Be 1 to 2. You're just switching that ratio. These triangles are similar. The smallest has to go with the smallest. So 15 has to go with 5. They're both the smallest number. Triangle ADX is the big triangle. So that's a ratio of 3 to 1. Triangle MYB is the small triangle. So that's a ratio of 1 to 3. These two, same idea, just different numbers. Number 13, we'll back up a second. The perimeter of triangle BDE is 72 feet. If triangle BDE is similar to triangle FMR, and the scale factor of triangle BDE to triangle FMR is 4/5, find the perimeter of triangle FMR. Okay, so we know our scale factor is 4/5, so I'm definitely going to use that in my proportion. And that's a scale factor small to large. So that's the smaller triangle because it comes first. It goes with the 4. Now, we know the perimeter of that triangle BDE. That goes with this guy because he's the small one, remember? You're going to put the 72 there. Find the perimeter of triangle FMR. Just cross multiply. I'm going to need some help on this one. 5 times 72 divided by 4. That's going to give us 90. You should get a bigger number. Remember, triangle FMR is the bigger of the two triangles.